My dear friends, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for your GATE and ESC preparation. So, very good evening, guys. Very good evening. I hope everyone is good, fine. And today we're gonna have the concept through questions of the very interesting subject that is industrial engineering. So, before starting the session, please do let me know whether my audio and video is all good, all perfect, no problem, no difficulty. Yes. Okay, very good evening. And please do share this video to all of your friends because I want everyone to be joining and enjoying this session and get the benefit of this. Okay, fine, perfect. Very good evening, Firdaus. Very good evening. How are you? So I hope everyone is so eagerly excited for the BARC examination. After a GATE examination, now the next destination is your BARC, and give your best for the BARC examination because this is an exam which you can actually crack if you're having a proper approach towards cracking. Okay, so let's begin the session, and I hope everyone has joined and shared this video to all of your friends. Okay, fine. So how is the preparation going on? All good? How many subjects covered? Because I think you have just prepared for GATE examination also, you've given the GATE, so I think all the subjects will be in touch, right? So I don't think so you won't be having that much of revision is required, but yes, before examination you need to practice questions in order to build that momentum, in order to have that revision to be consistent. Okay, chalo. So I hope so everyone has connected with me, and if you have not yet connected, please do join my Telegram channel, that is Learn with Suraj and Mechanical by Suraj. You can join that, and you can, I'll be sharing the PDF of that also in Mechanical by Suraj. Okay, you can do join, and all the latest notification of the class, even the important study notes, ebooks already being shared. Okay, chalo. And on 26th of March, that is today's 24, right? 26 March at 12:30, Rakesh sir will be coming live and we'll be talking about 1 year preparation strategy for GATE 2024. I think so this is a very beneficial workshop for all the aspirants who are planning to give in 2024, right? Apart from this, we are launching from 3rd of April ESC Mains 2023, a practice course for our mechanical, civil, electrical and E&T. A comprehensive coverage will be having detailed conventional practice session, and we'll be having evaluation of the question because you'll be writing some, we'll be giving you some assignments, and you'll be submitting that assignment, and we'll be checking, like even faculty will be checking that, evaluating according to your response. Okay, so from 3rd April we'll be starting, so please do enroll this starting from 3rd of April. Okay, chalo. So ready, guys? Top 10 questions will be there, which will be covering almost every topic, at least 80% of the topics, which is important for BARC examination perspective. Because BARC examination, its questions are very difficult to fetch, but we know what are the topics which they are touching in the last 3-4 years. So we'll be concentrating more on that particular topic. So let's go for the first question on your screen. And a manufacturer produces two products, product 1, product 2, production levels of X1 and X2 respectively. Good evening, good evening. The profit is 2x1 plus 5x2, and there are 3 constraints being given, production constraint. You have to calculate what is the maximum profit which will be meeting this constraint. Okay, so you have the objective function z maximum is equal to 2x1 plus 5x2, right? And there are 3 constraints: x1 plus 3x2 less than equal to 40, x1 3x1 plus x2 less than equal to 24, and x1 plus x2 less than equal to 10. So there are 3 constraints. A simple question from the graphical approach, and I hope so everyone has seen that graphical approach ground zero video. Those who are having a doubt in the graphical method, you can watch that and you can clarify your doubt. Okay, so what will be the maximum profit? 3 constraints I have written. Try to convert into intersect format. You'll be able to have very easily, you'll be able to plot this graph. Okay, so if I write the first constraint, I can write the first constraint as x1 divided by 40 plus x2 divided by 13.33 less than equal to 1. This will be the first constraint. Second constraint, I can write it like this: x1 by 8 plus x2 by 24 less than equal to 1. and third constraint I can write it like this: x1 by 10 plus x2 by 10 are less than equal to 1. Okay, so three constraints written in the intercept format. Try to plot, get the feasible region, identify the intersection points. Might be you will be having a redundant constraint in this question. Okay, if you try to solve, might be you'll be getting one of the constraint as redundant constraint. Chaliye, tell me what would be the maximum profit they'll be getting: 29, 38, 44 and 50. Option A, option B, option C or option D. Try to plot this on 2D curve. We can use the graphical approach, right? So if I try to plot this over here, we are having x1, we are having x2. So first constraint we are having 40 and 13.33. So we'll be having 40 over here, 13.33. I can plot it over here. So this is the first constraint for 13.33 and 14, and the constraint is basically less than equal to, that means all the values which is towards the origin will be concentrating. Second constraint is 8 and 24. So we'll be having 8 over here, 24 somewhere around here. So 8 and 24 will be the constraint that we will be getting towards the origin, right? Okay, and third constraint is 10 and 10. 10 will be somewhere around here and 10 will be somewhere around here, right? So this is the three constraints we are having. So is there any constraint which is acting as a redundant one? Yes, sir, it is. Very good, Rishi. Very good, correct. So we'll be having this this is the feasible region and this constraint is the redundant constraint. This is a redundant constraint. Very good, Rishi. Okay, fine. So let us take the corner points. Let us say this as point as A, this as B, this as C, and this as D. So coordinate of point A is not required. B is having a coordinate of 8, 0. The maximum objective value, that objective function is 2x1 plus 5x2 plus 5x2. Now D is having a coordinate of 0, 10. Now what's the coordinate of point C? C is an intersection of constraint number 2 and constraint number 3 and constraint number 2, right? This is constraint number 1. So it is an intersection of 2 and 3. So we need to solve these two equations. That means 3x1 plus x2 equal to 24. x1 plus x2 is equal to 10. Subtract this. x2 will be cancelled out. So x1 will be coming out to be 7 and x2 is equal to 3. So 7, 3 is a coordinate of point C. 7, 3. Okay. So let's, very good. Saurav, very good. Free fire. Option D is the correct answer. We are getting this as 50. So ZB is coming out to be how much? 16. ZC is coming out to be, this will be 14 plus 15, that is 29. And ZD is coming out to be 50. That means this is the maximum value that we are having. So we can say the final answer is this. Okay, can you tell me by looking at the option, because this is the feasible region, right? At point D we are having that, not feasible, optimum solution, right? Can you tell me which kind of solution we are getting? Can we say this is the degenerate solution? Yes. Can we say the solution that we are getting in this particular problem is a degenerate because one of the constraint is having a 0 value. So I can also say this solution is nothing but a degenerate solution. Degenerate solution, right? Fine, because the final optimal solution we are getting at x1 equal to 0 and x2 equal to 10. That means x1 is playing no role in identifying that optimal solution, right? That is the reason we are calling this as a degenerate solution. Chalo, next question on the screen. Now, these kind of question, basically you need to frame out, you need to create the objective function, you need to create the constraint. And normally this kind of question you can expect in BARC examination. Okay, so this is a furniture manufacturer produces chairs and tables. Let us suppose I'm assuming chair as C and table as T. The woodworking department can produce 200 chairs or 100 tables or any appropriate, any proportionate combination of these per week. The weekly demand of the chair and table is limited to 150 and 80 respectively. The profit from the chair is 100 and that of the table is 300. What is the sum of the optimum mixing for maximizing the profit? So they are saying what is the value of C plus T? what should be the optimum for maximizing the profit, what should be the total number of chairs and tables that we need to manufacture? This is the question that we need to answer. Chalo. Now, first of all, we need to frame out the objective function. Now, by clearly reading this third last statement, 100 for chair and 300 for the table. So, the objective function will be equal to maximization, because this is the profit. We have to go for profit. So, 100C plus 300T. This is the maximization, we can say, objective function that we are creating. Now, they are saying that woodworking department can produce 200 chairs or 100 tables in any proportion or any proportion combination per week. So let us suppose if I am manufacturing C number of chairs, so in 1 week, can we say the time required will be C by 200? Right? Can we say the proportionate time required for one chair will be C by 200? Right? Similarly, the proportionate time required for making the table is T by 100. And this total summation should always be less than equal to 1, because they are saying that you can have any proportionate of combination these per week. Okay, so if I talk about for 1 week, so C by 100, 200 plus T by 100 less than equal to 10, or I can say C plus 2T is less than equal to 200. So I got the first constraint. I have created the first constraint. C plus 2T is less than equal to 200. Second constraint is, they are saying that chair and tables are limited to 150 and 80. So chair should be less than equal to 150 and table should be less than equal to 80. So I got all the three constraints being created. All the three constraints I have created. Now I have to just calculate the final solution to this. Okay, let's see. Now this is exactly similar question as that of the previous one. We have formulated the objective function, the constraints being created, these are the constraints, right? And already this is in the intercept format, so I can plot this on the 2D plane. Let us say on the x-axis we are having C, and on the y-axis we are having T. Okay, so first constraint is 200 and 100. So let us say this is your C curve, 200 and this is 100. Okay, so 200 and 100, right, less than equal to. Second is C is less than equal to 150. So we'll be having a vertical line. We'll be having a vertical line, and this is your 150. And third one is T less than equal to 80. So we'll be having a line, this is, let us suppose 80, a horizontal line. Okay. So I got the feasible region, this as the feasible region. Fine. So let us suppose this is point A, this is point B, this is point, but I think they have given C and T. They have taken C and T. Let us take it as PQRS. This is point P, this is Q, this is R, this is S, right? Or we take it as origin is not required, no? Because maximization problem. P, Q, R, S. Okay. So coordinate of point P is 0, 80. Now coordinate of point Q. Q is an intersection of this line and this line. Okay. That means you have to take C plus 2T is equal to 200 and this one T is equal to 80. Okay. If you solve it, you will be getting this value. This will be 160. So you will be equal to 40. 40 and 160. Yes. You put it over here 160. So we'll be having 40, 80. Sorry, 40, 80. So Q will be having a coordinate of 40, 80. Now, if I talk about point R is an intersection of C plus 2T equal to 200 and C equal to 150. So if you place it, you will be having 50, 25. So it will be, R will be having a coordinate of 150, 25. S is having a coordinate of 150, 0. 150, 0. Right? Okay. Chalo. Now let's calculate the objective function, the maximum value. So Z max, objective function is Z max is equal to 100C plus 300T. 100C plus 300T. Let us calculate for individual points. ZP is equal to, what's the value of ZP? ZP will be equal to 24,000. ZQ will be equal to 40,000 plus 24,000. So this will be 64,000, right? Okay. ZR will be, what will be value of ZR? 100 into 150 plus 300 into 25. Can you tell me what's the value? ZR. Plus 300 into 25. You'll be getting, I think, 22,500. Okay. And ZS is having a value of 1, 2, 3. So maximum value we are getting at point Q, 64,000. Yes or no? Oh, this will be 4,000, right? It's not 40,000. 4,000. 4,000. So this will be 28,000. Yes. Are we getting 28,000 as a maximum value? And that is I'm getting at point Q. Yes. I'm getting this as a maximum value. हाँ definitely solve. ये clear हुआ? Are we getting 28,000 and that is at point Q? Yes. Okay. Fine. So I'm getting point Q as the optimal solution. Optimal solution we are getting, right? So the final answer is, they are saying what is the sum of the optimal product. So we are saying that C should be equal to 40, T should be equal to 80. So the optimal sum is 120. So you should be having the total sum of the optimal product should be equal to 120. 120 is the final answer. 40 plus 80. Saurav, 130 kaise yaar? 120, yeah, definitely. Now let us quickly recap how we have created. I think this is quite easy to understand, 150 and 80, right? Now let us try to understand a simple perspective. They are saying that you can produce 200 chairs, only 200 chairs in 1 week, okay? Or I can say 100 tables in 1 week, or we can have a combination of this in 1 week. Okay, fine. Is this clear? So can we say if I manufacture C amount, so can we say C by 200 is that this much of time is required in 1 week, right? This much time will be required. Let's take an example. Let us suppose if I manufacture 100 chairs, right? Okay, that means I'll be taking half week, because in 1 week I'll be able to manufacture 200 chairs. If I'm able to manufacture 100 chairs, that means I'm only taking only half week, right? So for the rest half week I can take the tables, right? Okay, so let us suppose C by 200 is the total number of we can say weekly time, we can say the total time required to manufacture for 1 week, and T by 100 is the total time taken to manufacture the table. And if I try to add, summation should be less than equal to always 1, because I'm talking about only single week. I'm talking about a single week. Okay, fine. You can understand by simple technique that I can simply say that if I try to make a table, let's say this is chair, this is table, okay, and if I say this is your woodworking department, right? Okay, so I can say in order to have the total, we can say number of chairs being manufactured is 200 chairs and number of tables being manufactured is 100. So I can say chairs and table is having a ratio of 200 is 200, or I can say C is equal to 2 times of T, right? Fine. Or I can say 1 is to 2, right? So I can say C plus 2T, take the higher value less than equal to 200. We can write it like this also, because the maximum limit that we can have is 200. If I manufacture table by 2 times rate, then we can have a total of 200. So I can say C plus 2T should always be less than equal to 200. Right? Is this clear? Because if I'm manufacturing 100 tables, then number of chairs to be manufactured will be 0. If I'm manufacturing 100 tables, then the chair should be having 0 manufacturing, right? If I'm manufacturing 200 chairs, then the table should be equal to 0. This is the equation. Now clear? A simple technique, right? 1:2 ratio. We can say C by T is having or T by C is having a ratio 1:2. Chalo. Next question, question number 3. You have to tell me the dual of this problem. What is the dual of this problem? Is it a degenerate? Is it an unbounded? Or is infeasible? Or we are having an optimum unique solution? Let's see who will be giving me the answer. How to calculate the dual? It's a very easy technique. You have to transport the rows into columns and columns into rows, right? So I can say, if I write it like this matrix 1, -1, 2, 0. Okay, if I try to transpose this, you'll be having 1, 2. So y1 plus 2y2 greater than equal to 2, and transpose over here minus y1 is greater than equal to 1. Okay, and 10y1 plus 40y2 is equal to z minimum. So I have converted, we have created the dual of this, right? So just you have to just plot it on a 2D plane. So I can simply write it like this: y is less than equal to 1. This is the second constraint. First constraint is this. Try to plot and tell me what is the correct answer. Now we are having a combination of greater than equal to and less than equal to. So definitely you will be getting an unbounded solution. But let us cross check, are we getting unbounded or not? Okay, so first constraint we can write it like this: y1 by 2 plus y2 by 1 greater than equal to 1. Right, this is the first constraint. Second constraint is already given. So let us plot this. Let us plot this. This is y1, this is y2. y1 is having 2, y2 is having 1. So this is the first constraint that we are talking about. Because it is greater than equal to, so it will be away from origin, right? Second constraint is y1 less than equal to 1. y1 less than equal to 1. So this is the feasible region that we are talking about. This is the feasible region we are talking about. So this is an unbounded. The region that we are getting is an unbounded region. Yes or no? We are getting an unbounded region. This region will be going on till infinite. Okay, so we can simply say the solution for this will be unbounded. Okay, fine, very easy. This type of questions are very easy to calculate. Only thing is you need to understand what is the logic to create the dual or any other formulation. Okay, chalo, next question. Now this is a question from the transportation model. Question is very interesting. If the demand of, they have already given some allocation, right? They are already given some allocation and the unit price is also being given. They are saying that if M1 increases by 1 unit and M3 decreases by 1 unit, then the total transportation cost will be, what will be the decrease? Will it increase by 5 or decrease by 5 or increase by 4, decrease by 7 or increase by 3? So this is the transportation cost. They are saying that M1 is increased by 1 and M3 is decreased by 1. Okay, this they are saying. Already they have given some allocation, right? So try to identify what will be the net change in the transportation cost. If the net change in the transportation cost is coming out to be positive, that means the cost is increasing. If the net change is coming out to be negative, then you can say that net transportation cost will be having a decrease in the previous one. Now we can say, so they are saying that M should be decreased by increased by 1. So I can say plus 1. So if this is being increased by plus 1, remember the concept of skipping stone method. So you have to make a loop. So this is plus 1, this has to be negative, right? Because if this is 6, then this has to be 4, because this is not increasing. This should be 10. If this is 6, this should be 4. If this is 4, this has to be increased by 1. This is plus 1. If this is plus 1, this has to be decreased by 1, minus 1. If this is minus 1, this has to be increased by plus 1. And this is minus 1. So I have already, because M3 is decreased by minus 1, that is also being done. So I have seen where you are increasing and decreasing. Can we say the change, net change that will be having? You are increasing by 4 rupees. So we can say 4, right? You are decreasing by 2 rupees. Let me go in this way. Decreasing by 18 minus 18. Increasing by 11 rupees plus 11. Decreasing by 2 rupees increasing by 7 rupees and decreasing by 9 rupees, right? So tell me, what is the net value you are having? Is it minus or positive? So 4 minus 18 plus 11 minus 2 plus 7 minus 9, you'll be having this value to be minus 7. Yes, minus 7. That means your total transportation cost has decreased by 7 rupees. So option C will be the correct answer. Option C is the correct answer. Is this clear? Simple question. But the only thing is you need to understand how you need to apply the logic. Okay, just you need to start from one side. Like they're saying plus 1. If you start from here plus 1, then it should be minus 1. It should be plus 1, minus 1, plus 1, minus 1. Automatically this condition will be satisfied. Let us suppose you say that, so I'll be starting from M3. You start from over here, minus 1. This will be plus 1, minus 1, plus 1, minus 1, and plus 1. So this way your entire process will be completed, right? Because the net, this is 15. So 11 plus 4 is 15. 11 plus 11 plus 14, right? Okay, 11 plus 14, that will be your 25, right? If I say 6 plus 4, that is 10. So that condition should be satisfied. You cannot surpass the total maximum limit of supply and demand. Okay, fine. Is this clear? So they are increasing this and they are decreasing this. This is 14, this is 6, and this is being satisfied. 14, right? You can say this is 6, this is your 4 plus 11, 15. This is 11 plus 4 is 15. Okay, fine. Question is easy, but only thing is you need to understand how you need to proceed this kind of question. Okay, next question from Queuing Model. This is one of the question which I usually take in many of the sessions because students do have difficulty in this. Okay, a railway reservation block has 20 counters. There are total 20 number of counters. The peak arrival rate is 150 per hour. They are saying that arrival rate, please check. Now it's all good, perfect. Let me check from my end also. I think that is being okay. Everyone, is my audio video now? It's good. Please check. Now I think that is there was some slight technical glitch that we had. Now it is being overcome, right? Let me check. Okay. Are we having any issue right now? Still you are having that problem going on. Okay. Okay, fine. All good, all good. Still slight buffering is going on. Okay. Now I think that is being resolved. Yes. Right. Okay. So now let's continue our discussion. The question was you have to tell me how many out of 20 counters, how many counters you need to open. Out of 20, how many counters you need to open? That is a question. So let's quickly go into this and let's try to solve this question as soon as possible. I think there is a problem going on. Now I think. One second, guys. Okay, so try to solve this. Yeah, now it's okay. Fine. So now they're saying that the service rate is of 5 minutes, right? So if the service rate is of 5 minutes, so I can say what will be the service time? The service time will be equal to, if every customer is taking 5 minutes to get served, so I can say 60 divided by 5, that is 12 customers will be served every hour. 12 number of customers will be solved every hour, right? Okay, fine. So now they're saying that the waiting time of the queue is limited to 15 minutes. So I can say WQ is equal to 15 minutes. I can convert this into hours. So this will be 15 by 60. That is 1 by 4 hours. Okay. So WQ we know, right? Now the problem over here is, okay, there's some problem going on. Let me cross check. Yes. Okay, now can we proceed? Yes, good to go. I think Saurav, Fikri. Okay, now I think we can continue our discussion. So they have said that WQ is equal to 1 by 4. That means your waiting time in the system or waiting time in the queue should be limited to 1 by 4 of the hours, right? Okay, but the thing is, the question is, there are total 20 counters. There are 20 counters. So out of 20 counters, how many counters you should be opening? That is the question, right? So let us suppose I'm opening n counters. Okay. Let us suppose I'm opening n counters, and they're saying that there's an equal distribution of the customers to all the counters. So can we say the arrival rate will be equal to 150 divided by n? If n counters are open, can we say each counters will be having 150 divided by n as the number of arrival rate, right? Okay, fine. So if this is the arrival rate and if this is your service rate, can we calculate the value of n by using the simple relation that WQ is equal to your LQ by lambda? What is LQ? That is rho square upon 1 minus rho divided by lambda. What is rho? That is lambda by mu. Rearranging this equation, I can say this will be equal to lambda divided by mu into mu minus. Yes, can we write it like this? Only some basic rearrangement. Only some basic rearrangement, right? Okay, fine. Is this clear? So now placing all the values, lambda is equal to 150, WQ is equal to 1 by 4. So 1 by 4 is equal to lambda is 150 by n, 150 divided by n. Mu is equal to how much? It is equal to 12. 12 into 12 minus 150 divided by n. So if I solve this, we'll be having n will be cancelled out. So 1 by 4 is equal to 150 divided by 12 into 12n minus 150, right? So this will be 3, this will be 50. So 12n minus 150 is equal to 50, or I can say 12n is equal to 200. So what's the value of n you are getting? Approximately 200 divided by 12, approximately you'll be getting 16.67. That means we can say nearest value should be 17. That means that out of 20 counters, you should be opening 17 counters. If you open 17 counters, I can say the waiting time on that queue will be equal to how much? 15 minutes. Will be 15 minutes. Okay, if let us suppose if you are opening all the 20 counters, then definitely the waiting time of the queue will be less. On the other hand, let us suppose you are opening only 3 counters, then the waiting time of the queue will be very high. Okay, so this calculation help us to understand how many number of counters should be there in any station. Like you might have seen, you go to a small station, the number of counters will be limited to 1, 2 or 3. But if you go to a bigger station, right, or if you go to a junction, there you might have seen that there will be 7 to 10 number of counters will be there, or more than 10 counters will be there. Because more counter means more number of customers, more number of passengers are daily visiting. If you're having a small station, there are not that much of number of arrival rate. That means only few counters will be required, okay, while operation. So that is the reason this queuing model is very effectively being used to identify how many number of counters should be there in every particular station, right? Okay, fine. So this is a question from the queuing model. Let us go with the next question from our very important, very famous, that is your critical path method, right? So there is a data being given. So you have to tell me what is the critical path. So I've just shifted that table on the right hand side so that you can see this. So what will be the critical path? Let us try to draw this diagram. 1, 2, 2, 2, 2, 3, 4, 2, 3, 1, 2, 4, 4, 2, 3, 2, 2, 5. Okay. So 2, 2, 5, 3, 2, 5, and 4, 2, 5. Right? So 1, 2, 2 is having 2, 2, 2, 3 is having 1, 4, 2, 3 is having 3, 1, 2, 4 is having 3, 2, 2, 5 is having 3, 3 to 5 is having 2 and 4 to 5 is having 4. So no, let's see what will be the critical path. Quickly, anyone who can tell me as soon as possible. Let me change the color. So this will be 0, this will be 0, this will be 2, this will be 3, this will be 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 2 is 8, 5, 8, 8. So we can say this will be the critical path. Yes. Can we say that 1, 4, 3, 5. 1, 4, 3, 5 will be the critical path, yes or no? Hai Yes. 3, 3 plus 3, 6, 6 plus 2 is 8. I think we are getting 8. Are we getting 8 or 9? We are getting 8 number of days as the total duration, and the critical path is 1, 4, 3, 5. And let's see the option. We are having 1, 4, 3, 5. Option B is the correct answer. 1, 4, 3, 5. Option B is a critical path. That is a critical path in the network. Right? Okay, next question on the screen. You have to tell me what is the latest finish time of event number 5. So very easy. You have to go with forward pass computation, then you have to go with the backward pass computation. Let's start from here. 0, 0 plus 2 is 2, 2 plus 7 is 9. This will be 3, 3 plus 2 is 5. So we'll be having 9. So this is 4, they'll be having 9. 9 plus 5 is 14. 18, 14 plus 3 is 17. Right? This is the forward pass computation, and the critical path, I think we are getting the critical path over here as this one. A, this one, right? This one and this one, right? And if I say backward, but they are saying the latest finish time of event number 5. So this will be 17. 17 minus 2 is 15. There is one pathway to reach event 5. So the latest finish time for event number 5 is 15 is the final correct answer. 15 is the final correct answer. Yes? Right? Okay, can you tell me what will be the total float of activity G? What's the total float of activity G? Can anyone who can tell me? What's the total float of activity G? Simple technique. We know the formulation. This is G having a duration of 2. This is 7. This is your 5. This is 9, 15, 17 and 17. So total float will be equal to cross calculation. 17 minus 9 minus 2. So this will be equal to 11, that is 6. So 6 days will be the total float for activity G. Just for additional information, because sometimes you can expect question like total float, free float, or your independent float. If I talk about a free float, that will be 17 minus 9 minus 2, again 6. If I talk about your independent float, that will be 17 minus 15 minus 2, that will be simply 0. That will be simply 0. So independent float will be 0. Okay, fine. Chalo, very good, very good. Question number 8 on your screen. Easy, hai, बहुत easy. PERT analysis. A question from PERT analysis. I want answer from everyone. They are saying that there is an activity whose optimistic time, pessimistic time, and most likely time is being given. So can we calculate the value of estimated time of completion? That will be pessimistic plus 4 times of most likely plus optimistic time divided by 6. So this will be 21 plus 4 into 15 plus 9 divided by 6. So this will be 30 plus 90. This will be 15. Okay. They are saying that what is the probability of completing this activity in 13 days? That means scheduled time is 13 days. Okay. We need to calculate the standard deviation. Standard deviation is equal to pessimistic minus optimistic divided by 6. Pessimistic is 21, optimistic is 9 divided by 6. So this will be equal to 2. So standard normal variate is scheduled time minus the expected time divided by the standard deviation. So this is basically scheduled time is how much? 13 minus 15 divided by 2. You are getting minus 1. So can you tell me when z is equal to minus 1, what is the probability? For probability of z is equal to minus 1, can we say this is 1 minus probability of z equal to 1? So this is 1 minus 0.84, that is 16% is the answer. Option A is the correct answer. Option A is the correct answer, right? This is for z equal to 1, this is z equal to 1, this is z equal to 0. This is somewhere we'll be having between, we can say, -1 and 0. Option B will be between -1 and 0. 34%, that means less than 0 but greater than 1, greater than -1. Okay, fine. So we are getting option A, simple, straightforward. Option is the correct answer. Okay, very good. Done. Fine. Okay, can you tell me if your scheduled time was 17 days? If your scheduled time was 17 days, can you tell me what will be the correct answer? If your TS instead of 13, if it would have been 17 days, then what will be the probability of completing this activity? Sir, if TS was 17, so 17 minus 15 is 2, 2 by 2 is 1. So for Z equal to 1, your answer will be 84%. Then your answer will be option D. Your answer will be option D. Very good, Rishi, Saurabh, very good. Okay, next question. Fine. There's a question very interesting, actually easy, but slightly calculated. Oh, I won't say calculated, slightly logical based. They're saying that the total, the ratio of the total variable cost for any quantity of Q to the total variable cost at EOQ is 1.25. They're saying that the total variable cost at any Q divided by the total variable cost at EOQ is equal to 1.25. Then what is the ratio of Q by Q star? What is the ratio of Q by Q star? Can you try this problem? What is the ratio of Q by Q star? Question is easy. Only thing is you need to apply slight logic. That's it. Now, if I say for any order size, I'm not talking about EOQ. So at that point, can we say that is nothing but the summation of holding cost and ordering cost? I can say this is nothing but D by Q into CO plus Q by 2 into CH, right? And at EOQ, can we say that is nothing but under root of 2DCOCH? Let's say this is equal to 1.25, right? Let us try to divide this term individually. I can simply say D by Q into CO, D by Q into CO divided by under root of 2DCOCH plus Q by 2 into CH divided by root of 2DCOCH. This is basically equal to 1.5, already given in the problem. Now, I can rearrange this equation. Can I write it like this? Q by 2, 2DCO by CH. Yes or no? Please check. Can I write the first term as like this? Q, no, it will be, Q will be in the denominator. It will be 1 by 2Q. Yes, can I write it like this? 1 by 2Q, because I need that under root of 2DCO by CH like this, because I want this to be a Q star. And I can write this equation as Q by 2 into under root of CH divided by your we can say 2DCO. Yes, that is equal to 1.25. Can I write it like this? Please check. I've just rearranged that equation so that I'm able to formulate some results. Now, what is 2DCO by CH? That is equal to Q star. Q star by 2Q plus Q by Q star. That is equal to 1.25. Multiply 2. I can say Q star by Q plus Q by Q star is equal to 2.5, right? Let us assume I'm assuming Q, what we need to calculate? We need to calculate Q by Q star. Let us assume Q by Q star is equal to X. Q by Q star is equal to X. So I can say this is equal to 1 by X plus X is equal to 2.5. Can we solve this kind of equation? Can we solve 1 by X plus X is equal to 2.5? So this is a quadratic equation. X square minus 2.5X plus 1 equal to 0. Can we solve this equation? What will be the root of this equation? Simple. Because already I have assumed X is equal to Q by Q star, whose value we need to calculate, right? So I can say just use the basic quadratic equation format. So X is equal to minus B plus minus under root of B square minus 4AC divided by 2A, right? So this will be 2.5 plus minus. Now solve this. Are we getting a perfect root or not? Can you tell me? 2.25 plus 6.25. So 6.25 minus 4 is 2.25. 2.25 root of this divided by 2. So this will be what? How much? 1.5. So 2.5 plus minus 1.5 divided by 2, or I can say we're having two possibilities. One is 2.5 minus 1.5 divided by 2, or we can say 2.5 plus 1.5 divided by 2. So this will be 0, 1, 1 by 2, right? This will be your 4 by 2, that is. So there are two possibilities, 1 by 2 and 2, right? So I can say your Q by Q star are having two possibilities. Either this value will be equal to 1 by 2, or your Q by Q star will be equal to 2. There are two possibilities, right? Okay, now let's see the option. What option we are having? Your option having is option C, 2. We are having simply this option as option C, 2. Okay, is this clear? So it's very important that how you are reading the question, how you are proceeding with the solution, that is important, right? Okay, so here we are getting 0.5 also and 2 also. If this would have an MSQ problem, let us suppose in gate level, if I say MSQ problem, then we can have 0.5 and 2, both answers are correct. But in BARC examination, we'll be getting only one single, right? Only one single answer as a correct. So I think option C is the correct answer. Okay, chalo, last question on the screen. The machine shop processes custom order, having a variety of clients. A machine entering in a job for a local manufacturing company has 5 unprocessed job remaining at a particular job time. So they have given some job 1, job 2, job 3, job 4, job 5, and they are entering in the job. They are saying that you have to follow the shortest processing time rule. Then what is the ratio of mean flow time to the average tardiness? So first of all, tell me what will be the sequence that you should do. You should be following according to SPT rule. What should be the sequence? So I've just shifted my side. You can tell me the sequence quickly. If you see clearly, 1, 2, 3, 4, 5. So the least one is of J4, J4, then J5. Then we'll be having J1, then J2, then J3. J1, J2, J3. Right or wrong? Are we having this as the, according to SPT rule, this as the sequence? First will be J4, then we'll be having J5, then J1, then J2, then J3, right? Let us write the same in the table. So, 4, 5, 1, 2, 3. J4, J5, J1, J2, J3. अब क्या हुआ? So J4 is having a duration of 4. Due date is 36. J5 is 5, 35. J1 is 13 and 65. 13 and 65. 48, 32. 48 is a due date. And J3 is 34 and 34. Okay, 34 and 34. Right? So job flow time is 0 plus 4 is 4. 0 plus 4 is 4. 4 plus 5 is 9. 9 plus 13 is 22. 22 plus 32 is 54. 54 plus 34 is 88. Yes? Yes? Oh, sorry, this will be, yes or no? Yes? Are we getting this value? Please check. 4, 9, 9 plus 13. Processing time of this was 13. This was 13. And 13. Again, this problem is coming. Okay. Right? So, we are having this has to be 22, 22 plus 32, that will be 54, 54 plus 44, that is 88. So, tardiness is my job number 1 a tardy job? Job number 1 is not a tardy job. Job number 2 is not a tardy job. Job number 3 is not a tardy job. Job number 4, yes, definitely that is a tardy job. 54 is the job flow time. It should be supposed to be completed in 48. So we'll be having 6 as a tardiness. Can you tell me the last one? It was supposed to be completed in 34 days. I'm completing in 88. So 88 minus 34, that will be simply 54. Yes. So total tardiness will be 60. Total tardiness will be 60. So I can say average tardiness will be equal to 60 divided by total the job is 5, that is equal to 12. Okay, and what is the mean flow time? Mean job flow time. So it will be 4 plus 9 plus 22 plus 54 plus 88 divided by 5. Can you tell me what will be the value? 4 plus 9 plus 22 plus 54 plus 88 divided by 5. 35.4. Right? And according to question, they are saying what is the ratio of mean flow time and average tardiness? So 35.4 divided by 12, whatever value you are having, that is the final answer. Divided by 12, 2.95. 2.95 is the final answer. Up to 2 decimal, so 2.95 is the final correct answer. Right? So in this question, we have taken up a simple question from the sequencing model where we have used the shortest processing time SPT rule in order to calculate the mean flow time. Right? Okay. 34 is na? 34. Okay. Right? Is this clear? Fine. So these were the 10 expected questions from the BARC level, and many of the students have already given their best results in 2023. I want you guys also, your photograph to be there when you will be cracking the BARC examination, right? So stay motivated and give your best in this BARC examination, because might be if your gate didn't went well, this is also one option that is in front of you which you need to capitalize. Okay, so give your best, and if you're having any doubt or difficulty, feel free to contact me on my Telegram channel, right? And I'll be sharing this PDF right now after the session. But I think so you have already practiced these questions, so won't be required. But yes, for later on session for practice, you can definitely download and you can save it for yourself. Okay, so thank you guys for joining with me. This is Suraj Gopi signing off. I hope you all guys enjoyed the session, and for more such awesome content, stay connected with BYJU'S Exam Prep. Thank you, bye bye, take care, and all the best for your BARC examination.